Welcome into the first installment of Beyond the Forecast. I'm meteorologist Steve Fendero, joined by Chief Meteorologist Jeff Edmondson in the beautiful Wavy Plus studio, newly renovated. We got all these fancy toys, microphones, cameras. Look at all these computers, switcher boards. We feel like we're on like a professional podcast or something here. And Beyond the Forecast is going to be a fun little addition to Wavy TV, and it's going to be something really cool that we're going to be able to dive into topics and things that you don't typically see on TV.
It's a chance to geek out, and it's a chance to ask questions, for you to ask questions on what is going on with our weather. What is that weird cloud? What is this weird blue line with triangles on a map? What are all of these things in weather? So we're going to geek out and talk a lot about meteorology. We're going to talk about cool astronomy. We're going to talk about other things in the atmosphere, anything that kind of is related to science, and we can wrap our heads around it. We'll talk about it here. If we don't know what we're talking about, well, we'll just do it. No.
We'll do it. That's what we do anyway, right? No, this is going to be some really cool stuff, and that's the whole point, is that this is supposed to be fun, laid back, elaborate, and not necessarily tied to what's going on locally. We'll talk about stuff all across the country, across the world, across our atmosphere, or into outer space, a platform that Jeff can talk a lot about astronomy stuff and geek out that way here. So let's dive right in here, and we're going to focus on one thing that Jeff really wanted to talk about too, which was Thundersnow.
Yes.
We'll dive into one of my favorite things about meteorology, which is lightning. Fun fact: that was my 5th grade science fair project.
Really?
It was indeed.
Okay,
We'll get into it. Yeah, but you had someone ask you an interesting question.
Yep.
About Thundersnow.
Can you get struck by lightning during Thundersnow? So that's interesting. So let's kind of go back and think about lightning. Let's think
lightning
about
first. Yes.
Clouds and thunderstorms, and then we'll go into what Thundersnow is. Obviously, you kind of figure out it's thunder during snow, but there's a little more to that.
Yeah.
We'll get into details about that.
Because thunder and lightning, that's in the summer. That's a thunderstorm.
Yep.
It is a very, very specific setup for it to happen in the winter, for it to happen while it's snowing, that it's so rare. So let's take it one step at a time.
Yep.
Jeff's going to dive into lightning.
And this happens anywhere too. This doesn't just happen on Earth. This can happen on other planets with atmospheres. But
give Jeff a microphone, and he'll tell you more than the world.
Yes, we're going to eventually fly through the clouds of Jupiter on one of these episodes. That'd be fun. We have a cloud here. We have a cumulonimbus cloud, a cloud made of basically water, ice, and you get something that happens inside. You have an updraft, where the warm air is moving upwards. You have the downdraft, where the rain droplets or flakes falling, or the hailstones are falling. You get areas in the cloud where the air is moving up and down. That creates essentially a friction. We generate a charge inside of the cloud. We can see that here. Electrons. As that charge building up. You see the charge increasing on the ground, and eventually get that point to meet. That's where the cloud discharges, that energy builds up, and that's where we get the lightning. Lightning's super hot. So we get the lightning to form. It hits a tree, hits the top of a skyscraper, hits the ocean. It can hit the beach. So that's why we have to be careful in those situations. Lightning can strike out and down up to 10 miles away from the main thunderstorm. Let's look at some of the common types of lightning. Cloud to ground, common. Inside the cloud to cloud, common. Cloud to another cloud, that's a little bit more uncommon. Cloud to sky. Remember when I was talking to astronaut Scott Kelly many years ago, I was asking him, what is some of the coolest things that you saw when you were on board the International Space Station? He mentioned just seeing the lightning and seeing the clouds from the space station was one of the things, and that's that cloud to sky, that rare type of lightning bolt. But when you're orbiting the Earth every 90 minutes, well, it becomes a little bit more common if you're going over the right spot at the right time. We also have, he also mentioned too, lenticular clouds too, and other types of clouds, but we're sidetracking, so we're going back to lightning. So we have the different types of lightning here, cloud to cloud, cloud to ground. In a thunderstorm with rain where there's a lot of warm air. But once we get into a situation where it's colder, snow, now we're talking thundersnow. So Steve, have you ever heard thundersnow before?
Jeff, have never heard Thunderstorm before, and I have never been lucky enough to hear Thundersnow. It is such a rarity, as we
Rare.
talked about before, because it needs to happen in an incredibly specific situation or
Yes.
setup. All of the right ingredients in the atmosphere, which there are millions and millions and millions of them, have to be right for this to happen. I mean, we've probably seen the viral clips of Jim Cantori freaking out. "Ah,
Yes.
thunderstorm, beep, 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 cursing on air, freaking out. So it is a rarity, and it's because of, well, set up in the atmosphere,
Yes.
and where lightning tends to happen.
So if we're going to get lightning in a thunderstorm, you know this, Steve, we're going to get a lot of heavy rain with it too.
Yes, and it's gonna be an intense rainfall maker, an intense thunderstorm, intense shower.
Yes. Yeah. A day where there's drizzle, you're not going to get a thunderstorm. You're not going to get thunder and lightning. So with snow, we have to have a very dynamic setup. We have to have a very strong area of snow. We have to have something happening in the atmosphere to generate that charge, that friction essentially in the sky to do that.
It's got to be violent, basically.
Yes,
Yeah, there's got to
it
be a
does.
lot happening inside of that cloud that's producing snow. There's got to be a lot happening, a lot of air going up, a lot of air coming down, hectic stuff going on inside of that snowmaker.
For folks that live near the Gulf, for folks that live along the East Coast where there's nor'easters that form, you can get a strong storm to generate a chance for thunder snow. Rare, but that can happen. But I was in Iowa when I heard it. So I wasn't near a Gulf. I wasn't near an ocean. I wasn't near anything larger than a small lake. Saylorville Lake is one of the nearest lakes. Lake Laverne technically was a lake on campus, but that was like a pond. We're not talking about large bodies of water here. We're talking about small streams, small lakes. So that wasn't happening from that. That formed because the main storm system, the main low pressure was very strong and it was getting stronger. It was basically bombing out in a way. It was really becoming a really strong storm system. So we had the energy in the atmosphere, had the upward motion in the cloud, had snowfall rates of around 2 inches per hour, and that's what created the thunder snow. When I was on my bike going to class, I remember we got to class. I wasn't in a meteorology class. No one really cared.
It would have been. Could you imagine if you're going to meteorology 301
Later
or
that
some
day.
atmospheric dynamic class, and you got, did you hear that? Did you hear that?
Oh, later that day when we got to 301, we talked about that, and I think the whole session was blown out because we just talked about it.
That was a lesson for the day.
That was the lesson for the day. Yeah, that was a lesson for the day. So that was cool. But lightning, your favorite thing. So fifth
You got to go
grade-
up in the
Yeah.
atmosphere to get lightning.
Yes.
Trying to cue in our next graphic, but it was
Yes.
fifth grade. Mr. Toronto or Mr. Trenton's science class, and I just actively remember that the cloud with the charges, the pluses, the positive charges, the negative charges, the electron differences, and being like, that's how that happens. Every time I, get a shock on my foot on the trampoline or the static electricity from a balloon. That's it. Really? That's it? And I've been hooked ever since. I've just been waiting for the moment to tie it into snow. And one of the things that you talked about with the 2-inch, snowfall rates that you're talking about per hour,
Right.
the intense, the storm system, the area low pressure,
Yep.
sourcing a intense snow shower, a lot of air going up, a lot of air rising to produce a big, big thunderstorm maker. So that's one of the things that you need in these thunderstorm events. So let's talk about where some of this stuff happens in the atmosphere. you know?
Yes. Let's go through the layers of the atmosphere. So the layer the only thing that matters on this graphic is the bottom layer. That's a troposphere.
That's it.
That's it.
Yep,
All right. Move
there we
on.
go. All right,
Next.
move on.
Yeah.
Next graphic. That's it. I mean, we talk about all this stuff that happened. Yeah, go ahead.
So, I mean, when we have the other layers of the atmosphere, yes, things happen in those layers. You look at the mesosphere, you see the little things there, the noctilucent clouds, the meteors, the sprites. That's a whole nother topic. But that is something that happens in that part of the sky and that part of the atmosphere. The lowest part is where all the action happens. That's where we have the most air. As we go higher in the troposphere, all the way to the top of the troposphere, the tropopause, the air temperature generally goes down. Maybe one time we'll do a SKU-T talk. Do you have a big SKU-T, by the way?
I think we should get what we could easily make and
I have a
print
big
one.
one.
Bring
Yeah,
it
it's
in
in my
next time.
garage.
We'll talk about
Yeah,
SKU-Ts.
okay.
This makes the easiest way to describe this. So
Yes,
essentially,
I get so sidetracked. But
we don't have to go into all of the what's important about the layers of the atmosphere is as we transition to what happened recently in Hampton Roads
Right.
with that really, really loud thunder. But we want to talk, let's finish off your thunder snow. Happening in the troposphere, the bottom layer, lightning, thunder, it's the same thing. It's just an explosion in the sky.
yes,
It
it's
is
the Go ahead.
I just, that's how I describe it to all the kiddos in the school talks. It's, it's just an absolute explosion in this, and that's it. It's that discharge from the positively charged parts of the cloud and the negatively charged parts of the cloud. It's just basically a release of energy. When you have a thing building up, building up, building up, it's that release in a way.
And the thunder that we hear is the hot lightning itself. It goes through the air. As it travels through the air, it causes the air to heat up. When air is hot, it expands. Boom. So you're basically exploding the air in a way because it gets so hot, so fast, so quick.
So quick. Yep. All right. And recently across Hampton Roads, there was thunder that was really, really loud.
It was strange, and this can happen anywhere too. This isn't just a unique thing to Hampton Roads, but it all depends on what's happening in the atmosphere. So we talked about this earlier. In the troposphere, generally the temperature decreases as you go higher in the sky. So if you're sitting on an airplane, outside the airplane window, it's about 40 below. Generally, let's just assume that's the summertime setup. Air outside the plane at cruising altitude is 40 below zero, 40 below 0 Fahrenheit.
I'm not Celsius. Doing the math. I'm not doing. You think I can do the math on my head on that real quick?
You know this one? Oh, you know this one. 40 below Fahrenheit.
Oh, it's 40 below Celsius.
Yeah, that's something.
Okay, cool. He gave me a softball there. Yeah. I get to keep my job.
Yeah. So temperature drops. But in this situation, when the thunder is a little bit louder, there could be an inversion set up in the atmosphere. So the air temperature isn't dropping as you go higher in the troposphere. All of a sudden, there's an area where the clouds and the thunderstorms are where it's a lot warmer. So the cold air is trapped at the ground. As you go higher in the sky, it actually gets warmer. So that's where we get the inversion, and that's how we create the extra loud thunder.
And this is, it can happen anywhere here in the States,
yeah.
But it happened recently for us, and it was something that kind of caught a lot of people off guard because it was a chilly day. It was raining and like 40-something degrees out, and it was kind of, this is in the winter here. We don't hear thunder in the winter. I mean, every now and then we do, but it'd be a warm day or it'd be a classic kind of severe weather setup. No, this was something that really took a lot of us off guard. Friend, remember Brian Reese? He texted me. He was like, "This thunder's no joke," in the morning, and I was like, "Yeah, this is really, really loud," and it was because of the inversion that Jeff had alluded to. We essentially had warm air that came in over top of the cold air that was already in place, and warm air is very light. It's very buoyant. It floats. Cooler or cold air is very dense and very heavy. So the cold air that we had all day, past couple of days, just sunk down on the surface. It was chilly, it was rainy. The warm air came in, and instead of kicking out the cold air and kicking it out the door, it rose up over top of the cold air and was taking its sweet time mixing down, right? It was just kind of like when you leave a bottle of oil vinegar and oil and vinegar out, they separate. The oil is going to be lighter. It's going to float up to the top. The balsamic is going to be juicy and flavorful. It's going to sink down to the bottom. Now you have a separation in two different masses. In this case, two different air masses. Warm air on top, the cold air underneath. It's a lot easier for a thunderstorm to form in warm air, which was very much the case when that warm front came in the region here. So we had the warm air sitting over top. It produced a thunderstorm up above the cold air, so way up top. It was an elevated thunderstorm where the air was accessible for that to happen. But as we talked about lightning being basically an explosion in the sky, or as Jeff mentioned, the hot air coming out of that discharge basically just expanding the air so quickly, it's that pop of thunder. We hear the lightning as that. The sound waves travel just like louder, 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 louder. That sound is going to go out across, up, down, left, right. As that sound came down to the surface, we heard it. It got trapped in the cold layer underneath. So in a way, it kind of condensed the zone in which we could hear the thunder.
Right.
And we were then kind of hearing an echo. The sound waves were then bouncing off of the warm air above it and then back down to the ground and off of the buildings, kind of echoing around because the sound was put into a squished zone of cold air, and it just sounded a lot louder.
This happened many years ago, and it wasn't a thunderstorm that was passing by. There was some military activity, some training missions happening well off of the coast, and the aircraft were going faster than the speed of sound when they're training, as normal. Normally, you wouldn't be able to hear that so far away, but because an inversion was set up, it allowed those sound waves to kind of stuck, and then they came all the way back onto the shore, back inland. So a lot of people heard that too, and they're wondering, what are these sonic booms? It was something that was happening a long ways away because of the inversion in the atmosphere.
Yeah, it's like it would be the same as being in a room, really big room, and it's hard to hear someone way on the other side of the room, but if you shrink the room, you're going to hear them a lot easier because you're closer, and the sound waves are going to bounce off all that kind of stuff. So it was just a really cool and fascinating thing that for us, I think, is kind of pretty easily explainable and easily to grasp. And that's a situation where, hey, almost thundersnow. Wasn't snowing, but almost, because there was.
Have you ever played squash?
Squash, maybe.
Squash.
Maybe.
Like, in the side of a gymnasium, there's that room where it's like all cement and you have the ball and you play squash, kind of like tennis, but it's not tennis.
Yeah, of course. Oh, yeah.
I've never played squash.
Yes,
but I know that
maybe
room
not
is really
played it, but I know what you're talking about. Yeah, the
Yeah.
room's really echoey. Or
Yes.
racquetball, it's like, bah.
Yeah, exactly.
Shrink that down, you're going to hear it a lot differently here. So it was just some really fascinating stuff here. We've been chatting here for a good 20 minutes here, Jeff. Is there anything else you want to elaborate on
That was
or
20
go
minutes
on?
already? Wow, that was fast.
I think it was. Yeah, that was 20 minutes. Yeah.
Okay,
We're
well,
good.
that's a lot of topics for one day. Back to the sound waves, one last thing. There's a place at NASA Langley, and we'll bring this on a future episode, the experimental test range where they test their satellites that are going to distant planets like the Europa Clipper mission. That room, while it's designed to simulate what it's like in space for signals, it also has the same thing for sound waves too, because they act similarly in a way. So you can stand in one spot of the room, you won't hear a thing, and then you move over a foot, and all of a sudden you can hear everything in the room. It's wild.
Incredible.
So I'll show you some. We'll have some pictures, video of that in the future. It's fun.
It's really cool stuff. Hey, thanks for watching. If you watched through all 20 minutes of our first episode here, Beyond the Forecast here, we're still working out the kinks of the audio, the video. We're punching things over here, and by punching, I mean here, changing diagrams and things like that here. But we're gonna work through all the kinks to really bring you some cool content that is beyond the forecast. See what I did there?
Yeah, I like
See
it.
what I did there? That's
I
good.
like it.
Until next.